humanOS. Learn, master, achieve.
Are we sleeping less than we should? Some have now estimated that Americans sleep 3 hours fewer than we did before the Industrial Revolution. This is a really important thing to understand because we know that insufficient sleep causes widespread problems of our physiology and even behavior. So how much sleep do we really need, and are we getting less than we should? Is the United States experiencing an epidemic of chronic sleep deprivation? One way to approach this question is to have a better understanding of what sleep was like for natural living communities that are not exposed to the things that theoretically are robbing us from sleep, like television and artificial light and temperature-controlled environments, things like that. And by examining these groups, we can gain insight into the nature of human sleep under these natural conditions. And that is exactly what Dr. Jerry Siegel and colleagues did. Dr. Siegel is the director of the Center of Sleep Research at the Semel Institute of Neuroscience and Behavior at UCLA's Department of Psychiatry. His lab studies how REM sleep is controlled in the brain and the conditions that are created when it's not working correctly. He's also made great contributions to unravel the neuroanatomical, neurochemical, and genetic complexities of the condition of narcolepsy. And another fascinating aspect of his work is that he looks at how different animals sleep in order to determine the origins and functions of sleep itself. He's someone whose work I've admired for a very long time, and I had the good fortune to meet Jerry in Ascona, Switzerland at a narcolepsy symposium in 2009. So I feel really fortunate that Jerry could join us on the humanOS radio show today. And so to begin, let me tell the audience more about the recent study that he and colleagues did looking at hunter-gatherer communities. These groups are the Hadza of northern Tanzania, the San, which are hunter-gatherers in Namibia. They've been in the Kalahari Desert for at least 20,000 years, and the Chimani of the Andean foothills. All of the participants were fit, none of them were obese, and they all wore actigraphs which look at, in this case, both activity patterns and also light exposure. So what did Dr. Siegel and colleagues find? Well, probably one of the reasons why this study has gotten so much attention is because this population of people slept less than what had been assumed from natural living communities. On average, they slept between 5.7 to 7.1 hours per night. But it's really important to note that the period of time that they were sleeping was 7 to 8.5 hours. Now, what is the distinction there? It's simple. Normal people will not sleep 100% of the time that they are in bed. So even if you went to bed at midnight and woke up at 8 and you felt like you were asleep the whole time, the reality most likely is that you probably slept only 7 hours instead of 8. And so the thing to focus on is time in bed. So even though they're sleeping 5.7 hours to 7.1 hours, what's also really notable, and the thing that I think you should be focusing on, is the fact that they were in bed for 7 to 8.5 hours per night. How you should not interpret this is to say, okay, now I'm getting out 8 hours of time in bed, but actually I only need just a little less than 6, because that is the amount of sleep that these natural living communities get. That is not a correct interpretation of this. It's also really important to note, however, that if you are not getting 8 hours of sleep, you're getting less than that and you feel fine, then don't think that you need to go on to sleep medications to sleep more. Another really interesting finding is that all three groups showed similar sleep organization, and this suggests that they might all be expressing some sort of core sleep pattern to humans. So this might be, again, characteristic of true Homo sapiens sleep. It's an interesting finding. Let's say it were 100% true. Because of the environmental changes, the differences between their environment and ours, we might need a different pattern of sleep to get our best sleep. But I think it's also worth exploring, if we mimic that pattern, can this improve the sleep that we're getting today? It's definitely worth exploring. Another really interesting finding is that these natural living groups did not go to bed when the sun set, and instead they would stay up about 3.5 hours after it got dark. And they wouldn't wake up when the sun would rise, but they would actually get up an hour beforehand. So if it wasn't light that was determining the sleep period, what was it? And it seemed to be a change in environmental temperature that most tightly corresponded across all three groups with sleep initiation and sleep offset, or waking up. It's also interesting to note that over the course of a night, temperatures continue to descend to a low point, or to its nadir. In our modern world, we might set a thermostat at, let's say, 65 degrees, and then the temperature stays stable. Because so much of health is in response to environmental signals, maybe our sleep would improve if we slept in an environment where the temperature continued to drop until about 4 in the morning. It is good to note, however, that temperature ranges for these three groups across the year were somewhere between 50 and 90 degrees. That was the total range from the lowest point of the day to the highest point at night. There are plenty of people who are listening to this podcast who throughout the year are exposed to much colder temperatures. This doesn't mean that you should sleep with the window open if it's negative 20 degrees out, but it also might mean that smart thermostats in the future produce a continual drop in temperature over the course of the night. So let's say you set it at 65 degrees and it continues to drop to 55 or 58 by 4 in the morning. That might actually be a better condition for us to sleep in. That might allow for deeper sleep, for better sleep efficiency, for sleep to do a better job at all the things that you want it to do. But before we go and adopt all of these strategies as though they're true, I think what this study does is it gives us more questions to address. So I'd love to see research done on this specifically. I also can't help but think of zero drop shoes and how many people adopted them and ended up having injuries. In so many ways, we've acclimated to shoes that have much more cushion and change the way that we run. And it's not to say that there's not a valuable argument to be made for having zero drop shoes with very little padding. But when you go from one condition over your entire life to immediately adopting this new one, yeah, perhaps problems can happen. Similarly here, if you're used to sleeping in a room that's closer to 68 degrees and you try to put it at 50, you're probably not going to like it at all. And so if you do want to do some self-experimentation, I would make gradual changes, see how you do, give it a period of time, and see if that is providing any benefit that you can distinguish. And lastly, before we get to the interview here, another factor that was just fascinating to me was the pattern of light exposure that these groups experienced. When I educate on sleep, I recommend getting at least 30 minutes of outdoor light per day. I don't care when you get it. Just make sure that you get 30 minutes at least every day if you can, if the weather is not too inhospitable. What this group of different tribes showed is that peak light exposure took place at 9 a.m. in the morning. So they'd wake up before dawn. They'd continue to get light exposure after the sun would rise until about 9 a.m. And then, at least by noon, these people are usually seeking shade to get out of the sun when it's the hottest during the day, so between noon and 3. And then light exposure would then increase towards the end of the day once again. I don't think that this changes my own recommendations. Not everybody's going to be able to get a lot of sunlight at 9 a.m. You might have to be sitting on a computer, most likely. But because this light exposure pattern was consistent across all three groups, it might indicate that this is a pattern that our bodies have evolved to be exposed to. Again, whether or not morning light is going to have a disproportionate or way more valuable impact on our physiology and the alignment of our circadian rhythms is a question that is ongoing. But it is interesting to see what are these patterns with these natural living communities. So there are just so many interesting things that this study showed. So let me start by asking you, what was the original stimulus that got you thinking, I need to do this particular study?
I guess there are two different threads here. One is the idea that we used to sleep so much more than we sleep now always seemed a little bit of a stretch to me. But at the same time, I've been doing a lot of recording in animals, most recently in animals in the wild. So the idea sort of crystallized. We were doing a study of sleep in wild elephants in South Africa. And we're still doing it, actually. We don't really have definitive data, but I think it's clear that they sleep a lot less than elephants in the zoo, which, of course, makes sense. If you have a bale of hay thrown in your enclosure in the morning, you don't have to do a lot of work for the rest of the day. So
right.
Perhaps a good thing to do is just sleep. So the obvious question is, how did humans sleep before the modern era, before electricity? And of course, apart from getting a time machine and going backwards, there's no way to record people in the 1800s and see how they slept. But with a group that was studying the Chumani in Bolivia, so what we have is two groups in Africa, 1,000 miles, probably closer to 2,000 miles apart in Africa, but in the same general region of the tropics where humans are known to have evolved. And then the group in Bolivia is living at the furthest reach of the human migration out of Africa. Presumably, they're descendants of people who have migrated through Asia and then through North America and South America. So by looking at these three groups, I think you get a fair insight into how humans sleep under the conditions in which we evolved. And it turns out that their sleep is similar in many ways. And the only reasonable conclusion, I think, from that is that this must be the way our ancestors slept.
So you found that people were in bed 7 to 8.5 hours and they slept 5.7 to 7 hours. The National Sleep Foundation recommends 7 to 9 hours. And so based off of your findings, do you think that changes to these recommendations are warranted?
Well, I'm not making any recommendation about time in bed. I'm just dealing with this idea that people used to sleep 2 to 3 hours more than they do now, and with the message that sends, that we're almost all sleeping way too little. So, I think before you make a recommendation like that, you have to know what the consequence of the recommendation will be and whether it will be beneficial. And actually, what bothers me is that the ASDA and SRS jointly issued a statement in June saying that if you have less than 7 hours of sleep, regardless of any symptoms, you should see your healthcare provider. And that's not based on any evidence that such a visit will be beneficial. Yeah. And I think it will probably result in a prescription for sleeping pills, which will not be beneficial. So, but in terms of this distinction between sleep period and sleep duration, that's just the numbers you get out of these ActWatch measurements. And no matter how you record sleep, you're going to see a difference between sleep time and sleep period. If you do it with EEG, you'll score that as wake after sleep onset. And basically, the ActWatch does this similarly. And so there are a lot of relatively large studies using the exact same devices we use in just a cross section of healthy human populations. And in every case that I've seen, and there may be an exception, but the largest recent studies that I looked at, both the sleep period and the sleep duration measurements are actually higher than what we see in these three hunter-gatherer populations. So, I've tried not to emphasize that point. I'm not saying, that the most important thing about this study is that they sleep less than us. But what I will say is that the data is very clear that they don't sleep more than we do, and certainly not by the idea that we're supposed to sleep from sunset to sunrise, which would mean that that we're sleeping on average 12 hours or, allowing for some time to go to sleep, maybe 11 hours, even 10 hours. That's the message that's been getting out, that people used to sleep that much. And when the electric light was invented, followed by all the other things that are more recently invented, that this has decreased. And I think, people ask where these numbers came from. I think Edison himself was a big booster of not sleeping, not something I would advocate, and maybe took credit for allowing sleep reduction. But I don't think that sleep reduction actually occurred at all.
So do you think that light is having a greater impact on modern societies than it is on these natural living communities?
Yeah, I think there's no doubt that light has an impact. And I certainly agree, with all the work on light and blue light, recent paper by Thurkan and Dike on that, and the melanopsin system. There's no question that light delays sleep and probably reduces it to some extent. But of course, there are other things about our situation that might be increasing sleep. Having a comfortable bed, not having to worry about being attacked in the middle of the night, not having bugs crawling all over us. And of course, the temperature regulation may have both positive and negative effects. So my experiment is not to say what is the effect of adding or subtracting artificial light. That experiment's been done very well, and I certainly believe that. Light delays and can diminish sleep. But on the
Yeah.
the more fundamental question of whether we get a lot less sleep than we were evolved to have, that I think we've answered pretty clearly, and the answer is no. Which again doesn't mean that some people aren't doing that, of course.
So it's becoming more well known to modify and be mindful of your light environment across the day. And in the evening, dim environmental lights and put on blue blocking glasses so that you're not giving your brain a signal that it's daytime. Should we also be modifying our room temperatures at night to keep them perhaps colder than what is common in the US and around the modernized world?
I think would be something interesting to study. It's one of these things that after I saw it, it's of course obvious, but I'd never heard anyone mention it. And certainly the thought had never occurred to me. We know it's cooler at night under natural conditions. And I think a standard recommendation that a sleep doc would give to a patient with insomnia is, to lower the thermostat at night. I've been doing that for years myself, and people do sleep better when it's a little cooler. But of course, in the natural environment, that's not exactly what happens. What happens in the natural environment, again, something I hadn't given any thought to before this, but what happens in the natural environment is the temperature falls throughout the night. And not only humans, but earlier primates, any animal living above ground has evolved in a situation where the temperature at night is falling, because that's what happens. And, one of the hallmarks of civilization is our regulating temperature, and that's something that's gone. Even individuals that turn down the temperature probably don't have the temperature falling the way it does in the natural environment. So, it's an interesting thing to look at. The other thing we saw connected with that is vasoconstriction in the morning. So these people are waking up with cold hands, something many of us have experienced when we go camping, but they're doing it in summer and winter, even in the tropics. And, I doubt that many people in our, quote, modern society sleep that way. But, maybe we should try that. But again, this is basic research. We see this relationship. I'm not in a position to make recommendations, and certainly I don't recommend that people reduce their sleep.
Yeah, this is really important. So don't interpret this information, if you're listening, as license to cut into your sleep and not get adequate sleep for you. All right. Additionally, if you're getting, let's say, 7 hours per night and you feel good, then you don't worry about getting more. I think doing some self-experimentation to find the amount of sleep that you need to feel your best is always wise. I recommend everybody do that. I'm also going to do an experiment and make my room temperature colder than I have it now. I'm not going to do it abruptly. I'm going to do it probably a few degrees or a degree at a time over a period of time, but I will report back and write about this in a future post, probably talk about it on a future radio show, and let people know if I noticed anything interesting from it.
Depending on where you live, one way to achieve that temperature rhythm is to open your windows. But, I think increasingly people don't do that. And of course, in some places you open your windows, you're really going to freeze. So, or there's going to be noise and other things like that. So, I don't think that nobody sleeps that way, but I think that it's certainly a minority of our society that does that. And we don't know how this might correlate with insomnia or other sleep disorders. I haven't seen any studies. Maybe there's some things buried in the literature somewhere, but it'd be very interesting to search for that in the literature or to just do the experiment and see what happens.
Jerry, what else is notable about their environment? For example, what are they sleeping on and what are they sleeping under?
Well, each group sleeps somewhat differently. We describe the details in the supplementary data section. The SAN, which is the group that I work with, they're typically, they have like a thin blanket in a region with clear dirt. So they're sleeping on the ground and they may have another thin blanket on top of them. The Hadza have a similar arrangement. They sleep on an animal skin typically. The Chimani, I think they sometimes kind of weave little mattresses, and they have more substantial shelters, although they're open air. They are not entirely enclosed in most cases.
I have to wonder if some of this more extreme thermoregulation that these groups are placed under has anything to do with the leanness that they maintain. So the group in the study ranged between 18 and 26 BMI. Not one person was obese. And so because they're having to regulate their temperature without a lot of clothing and as much shelter at night and more, colder environmental temperatures due to the fact that, again, they're exposed to more natural elements, does this have anything to do with the fact that this group or these groups can maintain leanness? Now, obviously, there are so many different factors that are involved in energy regulation, but could this be one factor at play?
The metabolic rate of these individuals, of one of the groups, which is the Hadza, was examined by Ponser et al. And his colleagues, Brian Wood, his sort of main colleague working with the Hadza, are authors on my paper as well. But they did a completely independent study looking at the metabolic rate of the Hadza and found, to their great surprise, that although they are more active than groups in our society, the metabolic rate isn't higher. This isn't an area of expertise of mine, but I assume the idea is, that they're just adapted to this higher level of activity and they are not really burning a whole lot more calories. And I think, the amount of calories you burn in exercise is sort of not sufficient to account for the obesity epidemic, that the difference between sitting around doing nothing all day and being quite active doesn't account for the difference, at least across our society, in weight and in the occurrence of obesity. Now, it might be different in these groups, but obviously they don't have Doritos and other similarly attractive, irresistible foods that are bad for you.
So you're able to monitor sleep through activity, which is validated but limited. And you also looked at napping and looked to see if they were napping a lot. And it would be one thing if they're sleeping 5 hours at night, but also napping 2 hours during the day. Were you able to measure any other markers of sleep satisfaction? And for those who are listening, sleep satisfaction is different than sleep quality. Sleep quality has more to do with the architecture of your sleep. Are you getting adequate depth? Are you getting sufficient time in all the different sleep stages? Sleep satisfaction, while it sounds like it would be synonymous with sleep quality, it is a little bit different. Sleep satisfaction is entirely, how do you feel the next day? Do you feel you were restored by the sleep that you got? And so while you are certainly challenged by doing complete sleep studies, given the environment that you're studying these people in, did you capture any other measurement of sleep satisfaction in these people?
We actually are thinking of doing the PVT test on these individuals, but it's quite difficult because of the environment, and they haven't had any experience with computers, and it's sort of a strange task. But we did some pilot data on that, but we don't have anything to report. So that would be worth doing. But sort of the operational definition of being sleepy is having a reduced sleep latency, unless they're fighting it all the time, which certainly doesn't seem to be likely. The fact that they have so little napping seems to argue against their being very sleepy. But I think it would be good to do the PVT, and we're kind of set up to do it. And it's difficult because it's a question of what you compare it to and what environment. I mean, they're outside, and we're working with an iPad, and there's glare of the sun, and they think it's pretty funny task to be tapping on this screen, and most of them don't have any experience at all with that. So it's not as simple as you might think it is, but I hear you, and I'd like to get that kind of data. I just don't know whether it's possible.
So what are the next steps, Jerry? Are there plans to do more research with these groups?
Yeah, well, doing EEG recording, that certainly would get at this issue of sleep depth. But, as you can imagine, that's not a straightforward thing to do when there's no electricity. But, I do think that'll be possible, and it'll take a while. But, it's a very interesting question.
Well, that was super interesting. So thank you so much for doing this work and for coming on to the show.
Pleasure talking to you. Thanks a lot.
All right, Jerry, have a good one.
So let me conclude and summarize here. So this study looked at 3 different hunter-gatherer groups, and it found that there was a striking uniformity of the sleep pattern across all of them. And this is despite the geographic isolation from each other. And so what does this suggest? Well, it suggests that this observed pattern between all 3 groups is not unique to their particular culture or their environment, but is perhaps central to the physiology of us as humans, at least semi-equatorial locations where our species evolved. Things could be different as you move to higher latitudes. Another big point is that sleep duration, and I want to emphasize that sleep duration is, not the only thing that matters for sleep, but the sleep duration in these traditional human groups is more similar to the sleep in industrial societies than has been assumed. And I found that fascinating. And it kind of flies against conventional wisdom, which is that we sleep a lot less than our ancestors. And this is due to artificial light. I think that artificial light and technologies are messing up the timing of our circadian rhythms, and that is influencing the quality of our sleep. But these societies actually have a sleep period of 7.5 to 8 hours, but they're sleeping somewhere from maybe 6 to about 7 hours per night. So another big conclusion here is not to say, well, this means I only need 5 hours of sleep, because a lot of people will interpret that as getting only 5 hours in bed. You still might likely need 7 hours to 8.5 hours of time in bed, which is pretty much what I've always recommended. So what's next? Well, sleep also really strongly correlated with seasons, which I thought was not too surprising. So people during the winter would sleep about an hour more, and all of that variability would come around the sleep onset. So when people fell asleep and not when they woke up. Sleep occurs almost entirely at night, also not a surprise. So not a lot of napping during the day. And what I thought was probably one of the more interesting findings here is that sleep synchronizes. So when we sleep, it synchronizes with a reduction in ambient temperature at night, which then associates with a decline in our core body temperature. And this might have been a way that we've evolved to save energy by reducing the temperature differences between body and environment and consequent heat loss. So if our core body temperature is dropping and so is the ambient temperature, it might just be easier to conserve energy. Right? If your body's trying to maintain a temperature that's much, much greater, then it's got to work a lot harder to do that in a cold environment. What does that mean? Well, it could mean that, what we see is there's very big difference between the prevalence of insomnia in these populations. And we didn't really talk about that, but most of these cultures didn't even have a word for insomnia. Now, when it was described to them what they were talking about, some of them did say, yes, I have some trouble falling asleep, or I have some trouble maintaining sleep, but it was 1% to 2% of the population. Compare this to 20 to 30% of the population in westernized, industrialized cultures. That's a huge, huge difference, right? And so perhaps one way to optimize our own sleep is to try to recreate some of these environmental conditions. We talk about light a lot, getting enough light during the day, keeping your room dark, but maybe, and this was not clearly articulated in the interview, a lot of people will reduce their temperature of their bedroom just before sleep. But what I thought was interesting is, should we actually be adjusting the temperature of our homes prior to going to bed? So as the temperature starts to drop, that could facilitate this feeling of sleepiness a little bit better. And we lose a lot of heat through what are called radiator parts, so our head and our hands and our feet. And so if you're lowering the temperature and you're wearing a sweatshirt, you still can wick off heat and allow for this natural drop in core body temperature to take place. And that will then potentially facilitate the onset of sleep more reliably with less issues falling asleep, shorter delays in what's called sleep latency. So the time when you're trying to fall asleep to when you actually fall asleep. So really interesting stuff. And I hope they do more follow-up work and look at the sleep more closely. It would be really fascinating for me to see if there's any differences in the actual sleep itself. It's also really difficult to test in the field in this situation. From what I can tell from his work, since he studies things from narwhals to elephants to orcas, the challenge of the environment and testing rarely gets in the way. So, thank you again for being on the show, Dr. Siegel, and for all the great work that you do. And thanks everybody for joining me at humanOS Radio, and we'll see you next time.
Thanks for listening, and come visit us soon at humanOS.me.